Hey guys, Ms. Davis here. This is Unit 8, Skill 3, Solving Rational Equations. So pause the video to write down the essential question. What is the process for solving equations with rational exponents? In this case, rational, we're going to be looking at fractional exponents in equations. So now just to review what we did last video in 8.2, the rule is when there's a fractional exponent a over b, we're going to use that EOR again. So it's exponent over the root, meaning that the numerator, so the number on the top, goes in the exponent spot and placement to the variable, and over, and then the denominator is the root, so our root is going to be the number that's inside the little square root symbol or the root symbol, the check mark area. So we're going to first take a look at example 1 that looks familiar. We have learned how to do this in the past units. But we're going to use a different method that's going to apply to fractional exponents that are a little bit more complicated. So if it says to solve the equation, that basically means you're going to get x by itself. So your goal is to isolate when there's a square root symbol. We're going to box in what we're isolating, and in this case we're isolating the entire square root. And what I have written over here is that if there's no number in the root area, then there should be a 2. So draw in a 2 because it is the square root. So if we're going to isolate the square root, we first have to get rid of that 3. So add 3 to the other side, and we end up with the square root of x plus 1 equals 5. Okay, so that should look familiar. And what we've done in the past is we've raised this to the squared power and squared both sides, or sorry, to the second power, squared both sides, and then proceeded from there. Which you still can do as long as the root is a 2. So you can still proceed that way as long as the root is a 2, but we're going to teach you a different method using something that you already know how to do, and change it into a fractional exponent. So what we're going to do is we're going to look at what's underneath the square root is x plus 1. X plus 1 is currently being raised to the first power. So the first power is the exponent, and our root is 2. So if we apply EOR, we can rewrite this as x plus 1 to the exponent over root, so we're going to have to the 1/2 power, okay, is equal to 5. So this and this are exactly the same thing. I think I said it in last video, anytime you square root something, you're really just raising it to the power of 1/2. Okay, so the next step is to get rid of and to use reciprocal powers to get rid of the 1/2 so that we can get x by itself, because that's our ultimate goal. So what we're going to do is we're going to raise this to the reciprocal power. So what a reciprocal power is, you take 1/2, so take the 1 over 2 and flip it. So I'm going to then raise this whole thing to a 2 over 1 power. So I just flip the fraction around, and if I multiply those together, the 2's on the top and bottom cancel out, and the 1's on the top and bottom cancel out. So what you're left with is just x plus 1. And what you obviously also have to do to the other side is raise that to the 2 over 1 power. Okay, so you have to do that to both sides. So it's x plus 1 equals 5 to the 2 over 1, which is really 2. So 5 squared is 25. And then subtract 1 from both sides, and you end up with x equals 24. Okay, with these, you always want to do a check. So if I did a quick check, I'm going to squeeze it in here. Okay, so quick little check. The square root of, let's see, x plus 1, so I'm going to do 24 plus 1, does it, oopsies, minus 3, does it equal 2? So if I square root, this is 24 plus 1 is 25, square root of 25 is 5, minus 3, does it equal 2? Indeed, if I subtract, I get 2 equals 2, that's a check. Okay, so I'm going to go over here and just make a quick note that you are raising to the reciprocal power. That's what this step right here is called. So, and we're going to write it again below in the video, but raise to reciprocal, reciprocal, power, which I'm going to show if it was x plus 1 to the 1/2, then we multiply it by 2 over 1. So again, reciprocal just means flip the fraction. So another example of a reciprocal, if it was like 3 over 5, the reciprocal power would be 5 over 3. Okay? And that would, again, cancel those out. Those would cancel out, and so forth. Okay? So let's look at example number 2, where we don't have a square root, we have a cube root now. Let me just draw a little line here so we can separate the problem out. Okay, so our goal is to isolate x, and in this case we don't have anything that we need to add or subtract to either side of the equation. Like this one we had the 3 first, so we had to move that, but in this case we don't. So we're going to use EOR and to write the 4x minus 1 to a fractional exponent. So inside there is an exponent of 1, and our root is 3. So our exponent and our root, we're going to rewrite this as the exponent on top, so 1 over 3. So to the 1/3 power equals 5. Okay, so all we've done so far is convert it. We don't have to do that to the right side because we've just rewritten it. It has equal value. So now our next step is to use the reciprocal power method. So reciprocal 1/3 is 3 over 1. So I'm going to raise this whole left side to the 3 over 1 power. And I'm going to do the same thing to the 5. Okay, so by doing that, we have those guys canceling out there, top and bottom, and we're left with just 4x minus 1 equal to 5 to the 3rd power is really 5 times 5 times 5, which is 125. And then from there, you're just solving it like a regular equation. So I get 4x equals 126. Divide both sides by 4, divide by 4, x is equal to 31.5. Okay. So we just solved two equations that had radicals in them, and the radical meaning the root symbol, so they had the radical symbol in them, and we learned how to convert them to the fractional equation, or the expression, and then solve from there. Our next set of problems is going to solve equations with rational exponents, which means that we're going to have those fractions in there now from the get-go. So we're going to take a look at example number 1 within this section of example 2. X to the 1/4 power equals 5. How do we get x alone? So in this case, if there's nothing else to move to the other side, we're just going to raise this to the reciprocal power of, so I'm going to put parentheses, and I'm going to put the reciprocal of 1/4 as 4 over 1. So in this case, we've got 4 over 1 canceling out, oopsies, don't want a highlighter, 4 over 1 canceling out, and 4 over 4 and the 1 over 1 cancel each other out. So we are indeed left with just x on the left side, but we have to also remember to do it to the opposite side. And if you were to put this in the calculator, you just do 5 with the little caret, so it's 5 caret, and then control divide to get your fraction, and then 4 over 1. Okay? And then when you throw that right into your calculator, you get 625. Okay, so how do we get x alone? It's called, like I said before, raise to the reciprocal power. Okay, so we raise it to not 1 over 4, but to 4 over 1. Okay, so reciprocal meaning flipped. Okay, that's a parenthesis. All right, so next one down here, oopsies, number 2, we've got x to the 2/3 power. So what's the reciprocal of 2/3? Well, it's 3 over 2. So I'm going to raise it to the reciprocal power of 3/2 and do the same thing to the other side. Again, those cancel, so we're left with x equals, type this all right into your calculator, and when you do, you end up with 64. But one thing I want to make sure we note here is that if we had an original power that had a numerator that was even, then we have to add a plus or minus in there. Okay, so remember when we did like solving quadratics, anytime we square rooted at the end, that's square rooting, we had to put plus or minus in front because there technically is the positive and negative version of the answer. So I'm going to make a little note over here and say that you must have plus or minus when the original exponent had an even numerator. Okay, if it has an odd numerator, you do not have to put it in there. Okay, so we want to make sure that we are looking at even numerators must have the plus or minus in there. Okay, so just like for example number 1 previously, we did not have to have a plus or minus because our original exponent was odd. Okay, and then in the numerator. All right, so how do we get x alone is the same thing. I'm going to say raised to the reciprocal power, and in this case it was, if it was 2/3 on the inside, then it was 3/2. Whoa, that's not 3/2. So we would have 3/2 would be canceling each other out there. Okay, so flip on over to the next side. All right, so on this side, we're going to get into some more complex rational equations or rational exponent equations. So just some general steps are written over here on how to solve. For step 1, you're going to make sure you isolate the base and the exponent. Okay, so if I look at example 1, the base of this term is the x and the exponent is the 3/4. Now I don't like how that looks, so I'm going to do it again. So we got this is the base and the exponent. The 2 is not the base because the 2 is not being raised to the 3/4 power, so we're not going to identify that. Raise both sides to the reciprocal exponent, and so flip the fractional exponent. Solve for x. Okay, so just like normal, solve for x, and don't forget to add the plus or minus when the even numerator is in the original rational exponent. Okay, so step 1 for this is to isolate the base. So I'm going to get rid of that 2 by dividing both sides by 2 in the front. Those cancel. We're left with x to the 3/4 power equals 8. And just so we know that the numerator is not even, right? So it's an odd numerator. So we have an odd numerator, so I'm not going to have to add the plus or minus at the end, just so we're kind of having a heads up. So I'm going to raise to the reciprocal power here, which is step number 2. So it's going to be to the 4/3 power. Raise this one to the 4/3 power. And cancel, cancel. It's just x equals, type that right into your calculator. Oh boy, dog's barking. Sorry, I had to go give him some bones. All right, plug that into your calculator. You get x equals 16. No plus or minus again because there's no even original exponent in the numerator. Okay, number 2. In this case, the base is the 2x because there's parentheses around it. So the entire thing is being raised to the 2/3 power. So the entire base is 2x, so I'm going to put parentheses around the entire thing and raise it to the 3/2 power. And do the same thing over here. Okay, so in this case, those cancel, cancel. We're left with the 2x equaling the right side is going to end up with plus or minus 64. So just a little refresher and reminder, we had an original even exponent. So even numerator equals plus or minus. So that means we need to have the plus or minus in there, okay? Right there. All right. So then we need to continue solving for x to get x by itself. So divide both sides by 2, and we end up with x equals plus or minus 32. Okay, so positive and negative 32. As always, if you wanted to check it, you would plug this back into your original for x and make sure that both the positive and negative version of 32 equals 16 when you plug it in. Okay, so the next one down here, number 3, our base is the x and our exponent is the 2/5. So I'm going to isolate that and continue solving to isolate it. So I'm going to move the 5 to the other side, bringing down the 2x to the 2/5 power. We have an even exponent, so we should be thinking that, yes, we're going to need the plus or minus. Divide both sides by 2, divide by 2. We get x to the 2/5 power equals 4. And at this point, we need to reciprocal power it. So flip the power around, get 5/2. Cancel, cancel, and we're left with x equals, now don't forget the plus or minus, 32. Okay, so once again, just a little connection that we had the original even exponent, or the even numerator, links to that plus or minus at the end there, okay? Here we had to do it a little early because we raised to the reciprocal power, not at the very last step. We raised to it basically in the first step. So in this case, we had to do it first because we used reciprocal powers at the beginning, and this one we're doing at the end because we use reciprocal powers at the end, okay? All right, so example number 4 here, we have got The 3x minus 1 is the entire base because the whole thing is being raised to the 3/2. So I'm going to raise both sides to the 2/3 power. And I'm going to do it over here too. So 2/3, cancel, cancel. And we left with 3x minus 1 equals 27 to the 2/3 power. Plug it in your calculator, gives you a 9. We had an original power that's odd, so we do not need the plus or minus. So plus 1, we get 3x equals 10. Divide by 3, we end up with x equals, you can just leave it as 10/3. That's the most exact answer. You could divide it and round if it had rounding in the directions. All right, example 5 and 6, they look challenging, but really we're just applying some old skills and adding in a little new. So I'm going to isolate the base and the exponent. So the base is the whole parenthesis in this case, with the 3/2 as the exponent. And we're going to start by moving everything to the left side of the equation. So I'm going to take away that 1 that's not attached to the original parenthesis, because that -5 is going to go second. It's through multiplication. So I get -2560 equals -5 parentheses x minus 6 to the 3/2 power. All right, now these are attached through multiplication, so I'm going to divide both sides by the -5. And when I divide negative by negative, I get positive 512. And I end up with on the right side x minus 6 to the 3/2 power. All right, we're at the point where we have base to the fractional exponent. So we're going to raise this to the 2/3 power. Again, reciprocal power. Notice again that we have an original odd exponent numerator, so we are not going to have to use plus or minus. Okay, those cancel, cancel. Plug that left side into your calculator and get a 64 equals x minus 6. That's all that's left. We can drop parentheses at this point, add 6 to both sides, and end up with x equals 70. Okay. All right, last example here. I'm going to box in the whole parentheses with the 4/3 power and subtract your 4 to the other side to start isolating our variable. All right, so we end up with -80 over here equals -5, parentheses 2a minus 12 to the 4/3 power. All right, thinking ahead, we have an even exponent, so we should be thinking plus or minus at the end. Divide both sides by that -5 hanging out front there. We end up with 16 equal 2a minus 12 to the 4/3. All right, we're at the point now where we need to use our reciprocal powers. Yes. And do both sides to the 3/4. Cancel, cancel. 16 to the 3/4 power is going to give us a plus or minus 8. Okay, so plus or minus 8. So remember, we have the even original numerator, so that's going to cause us to do this right here. I'm going to draw an arrow. Okay, so plus or minus 8 equals, and then whatever's left inside the parentheses there. And then go ahead and solve from here. But because there's more than one step, we're going to need to set this up, so meaning it's not just add something to both sides. We have 2 steps we have to do, divide by 2 and add the 12. This means that we're going to separate this into 2 separate equations, okay? So I'm going to have the positive 8 equaling the 2a minus 12, and the negative 8 equaling the 2a minus 12. I'm sorry, apparently my neighbors are not allowed to be outside anymore. Okay, so we're going to just then solve both sides of the equation, one with positive 8, one with negative 8. Okay, so equals 20, 2a divided by 2, we end up with 10 is equal to a, and then do the same thing over here. All right, equals 2a divided by 2, 2 is equal to a. Alrighty, so just want to reiterate that the reason why we had to separate it out here is because we had 2 operations to do in order to solve for a. So since we had 2 operations, we were able to, or we needed to separate it out, one to the positive and one to the negative version of 8. But up above, when we had up here, all we were doing was one step, was just dividing by that negative, or by that 2. Wouldn't have changed the validity of the answer, because positive 64 and negative 64 divided by 2 would give us a positive or negative 32. Okay? All right, so go ahead. We're done with the video. Write your summary quick and start your practice problems.